So now this one is question 2017, question 9b. Right then. Right, question asks me to define pH, and then I'm given the pH values of 3 acids, and I'm also given their molar concentrations, and I've got to account for the difference in the pH values between HCl and sulfuric acid and HCl and methanoic acid. Okay, so let's run through this first part then. So the first part says define pH. So pH is equal to minus the log of the H plus ion concentration. That's my first part. Now it says, this one here, sorry, the pH values of 0.1 molar solutions of sulfuric acid. Okay, so I've got sulfuric acid, I have HCl and methanoic acid. HCl, methanoic acid is your first HCOOH. Now, you're given the molarities of them. It says the pH values of 0.1 molar, so they're 0.1 for each of them. And we're told the pH values are 0.71 and 2.37. The pH values 0.7 for the sulfuric acid, 1 for the HCl, and 2.37 for the methanoic acid. Okay, so this is information given. And then it says, in terms of hydrogen ions, account for the difference in the pH values between HCl and sulfuric acid. Okay, so we've got a HCl and a sulfuric acid solution. So account for the hydrogen ion differences. Okay then, well, they've both got, this one, HCl, has a pH of 1. So pH equals 1 means minus the log of the H plus ion concentration is equal to 1, which means the H plus ion concentration is the antilog of minus 1, which is 0.1. Okay, the pH concentration of this one, the hydrogen ion concentration of this one, well, the pH of the sulfuric acid is 0.7. So this means the pH is minus the log of the H plus ion concentration. So minus the log of the H plus ion concentration is equal to 0.7, which means that my H plus ion concentration in this case, when I get the antilog of 0.7, this becomes 0.2. Okay, account for the differences. They're both a 0.1 molar concentration. Why is it that the hydrogen ion concentration in the sulfuric acid is 0.2? Okay, so that's because if you look at this dissociation, HCl dissociates into H plus and Cl minus. This one dissociates into 2 H pluses and an SO4 2 minus. So the H2SO4 has twice the number of H plus ions. So sulfuric acid has a higher concentration of H plus, so lower, so a lower pH. Okay, so this is your difference account for the difference in the pH values. So this is why you have a lower pH here, because they have double the amount of H plus ions. So higher concentration, double the concentration of H plus ions in H2SO4. Okay, next one. Account for the difference in pH values of 0.1 molar hydrochloric acid and 0.1 molar methanoic acid. Okay, so again, let's have a look. We know what's happening with the hydrochloric acid. That's this one here. We know what's going on there. So let's look at the methanoic acid. Okay, the methanoic acid. So this is the second part now. Methanoic acid is HCOOH, and we're told that its pH is 2.37. Okay, so this pH of 2.37, where's it coming from? It's minus the log of the hydrogen ion concentration is 2.37. So here the hydrogen ion concentration is the antilog of minus 2.37. And when you put that into your calculator, you will get 4.266 by 10 to the minus 3. So this is a very low concentration of H plus ions. So H plus ion concentration here is very low. since you have very low dissociation because it is a weak acid. It's a weak acid. Now, even though it's a 0.1 molar concentration, it's not all dissociating into its ions. So it's a weak acid. Okay, next part says, use the pH value given for the methanoic acid, so a pH value 2.37, to calculate the value of the dissociation constant for methanoic acid. So let's do that bit first then. So we're going to use a pH value. So it's a weak acid. So first of all, we know it's a weak acid. So let me just straighten this, girls. Okay, so if it's a weak acid, the pH, so we've decided now it's a weak acid. Methanoic acid is a weak acid, which means the pH, to get the pH of a weak acid, is minus the log of the square root of the Ka by the molarity. The pH, I'm told, is 2.37. So this is minus the log of the square root of the Ka. Now, the molarity, remember I'm told in the question, the molarity is 0.1. So this is multiplied by 0.1. Okay, so let's work this out. Let's get the antilog of minus 2.37, which we already know anyway, because we got that in the first part. That's 4.266 by 10 to the minus 3 is therefore equal to the square root of Ka by 0.1. So get rid of that square root on the right, square both sides, and we get 1.82 by 10 to the minus 5 is equal to the Ka by 0.1. We'll get the Ka then by dividing the 1.82 by the 0.1. So this becomes 1.82 by 10 to the minus 4 is equal to the Ka for methanoic acid. Then last part says, use then your value for 0.1 molar methanoic acid to calculate the pH of a 0.05 molar solution of methanoic acid. Okay, so we know the Ka for methanoic acid. We know the molarity of this solution. Let's find the pH. So this is another solution of methanoic acid. Okay, so the last part is the pH, remember, for methanoic acid, which is a weak acid, is minus the log of the square root of Ka by molarity. So this is going to be minus the log of the square root. The Ka I have found to be 1.82 by 10 to the minus 4. The molarity of this particular solution, the question tells me, is 0.05. So I'll work that out to get minus the log of, that all becomes 3.016 by 10 to the minus 3. And when I put that into my calculator, I get a pH of 2.52.